All right, let's dive in. We're going to break down the hidden architecture that powers, well, pretty much our entire connected world. We're talking about the fundamental building blocks of computer networks. I mean, have you ever really stopped to think about it? You click on something, and in a blink, information from halfway across the globe just appears on your screen. How in the world is that even possible?
Well, here's the secret. It's not some single, massive, complicated system. Nope. It's actually a collection of pretty simple, scalable building blocks that just fit together perfectly. And today, we're going to take a look at each one, starting right from the ground up.
So, our journey begins small, really small. We're starting with the network you're almost certainly using right now, even if you don't think about it. It's called the Local Area Network, or you've probably heard this one, the LAN.
And a LAN is pretty much exactly what it sounds like. It's local. We're talking about a network that's stuck in one small, limited space. Think about the computers in a school computer lab, or even better, all the devices connected to your Wi-Fi at home, your phone, your laptop, your smart TV, all that, that's a LAN. The computers in a single office building, also a LAN.
Now, these LANs basically come in two main flavors. First, you've got your classic wired LAN, the one that uses those physical Ethernet cables plugged into the back of your computer. And then there's the one we all know and love, the wireless LAN, or Wi-Fi. It does the exact same job, just using radio waves instead of all those messy cables.
Okay, so let's just sum that up real quick. A LAN, it's small scale, a single room, a building, maybe a campus. It uses gear like hubs, switches, and routers to connect everything. And the perfect everyday example, your home Wi-Fi network. That's a LAN in action, right there.
All right, so that covers a single building. But what happens when you need to connect, say, a few different buildings all across a city? Well, that's where our next building block comes in, the MAN.
The Metropolitan Area Network, or MAN, is the totally logical next step up in scale. It's specifically designed to connect users and their LANs across a much bigger area, like an entire city.
So you can think of a MAN as the backbone that connects a bunch of different LANs. Here's a great example. Imagine a supermarket chain that has 4 stores scattered across a city. The MAN is what lets the local network in each of those stores talk to each other. That way, an employee at one shop can instantly check the stock levels at another one across town. And it does this using things like routers and bridges to build those citywide connections. Okay, so we've gone from a single room to a whole city. What's the next jump? Yeah, you probably guessed it. We're going even bigger. We're going national. We're talking about the Wide Area Network, or WAN.
Now, a WAN is a network on a truly massive scale. We're not just talking about a city anymore. We're talking about connecting places across an entire state, or a whole country, or even between different countries.
Really, the number one thing that defines a WAN is distance. It takes all those smaller LANs and MANs we just talked about and links them together over huge geographical areas. For instance, think about a big company with an office in New Delhi and another one way down in Chennai. A WAN is the magic that lets a computer in one of those offices talk to a computer in the other one as if they were right next to each other, even though they're thousands of kilometers apart. Okay, let's hit pause for a second and just do a quick recap. We started with the LAN, super local, like your house. Then we scaled up to the MAN, which covers a whole city and connects a bunch of LANs. And finally, we have the WAN, which goes big, national scale, linking networks over massive distances. See how they work? Each one is just a bigger version of the last, growing in scale and reach. So we've gone from a single room to a city to an entire country. So what's the final ultimate building block? What happens when you connect all of the networks together? You get the internet. That's what it is. The internet is basically the ultimate WAN. It's not one single thing. It's a worldwide network of networks that connects, well, literally everything. And that's exactly why you hear people call the internet a network of networks. It's because it connects a countless number of those individual LANs, MANs, and WANs from all over the planet into one giant connected system. So when you send a message from, say, India to someone in Australia, that data is just hopping through this massive global web of routers, crossing oceans and continents in milliseconds. It's all of our building blocks working together on a scale that's hard to even wrap your head around. Okay, so we've built this incredible global network. It's amazing, but what does it actually mean for us in our daily lives? Why should we care? Well, it's pretty simple. It powers pretty much the entire way we live and work today.
Just think about three huge trends that would be completely impossible without this network infrastructure. First up, you've got Bring Your Own Device, or BYOD. That's the idea that employees can use their own personal laptops and phones to securely connect to their office network from anywhere. And that, of course, leads right into online collaboration. Teams can work together in real-time meetings from different cities, different countries, without anyone ever having to get on a plane. And what powers all of this? Cloud computing. Every time you use something like Google Drive, you're just storing your files on some server somewhere out there in the world and then accessing them whenever you want from any device. That is the power of this global network, right there in your hands.
So, there you have it. From the tiny LAN in your home all the way up to the globe-spanning WAN we call the internet, these are the building blocks that have connected our devices and our data across the entire planet. Which, of course, leaves us with one last really interesting question to think about. We've connected our data. What or who are we going to connect next?